Mutually exclusive events. Please stop the talking, ladies.
It's like a thing that only some stuff's allowed in.
All right, we're listening. Two events. Shush. Two events are mutually exclusive if they can happen at the same time or cannot happen at the same time. Can or cannot. If they're mutually exclusive, they're excluding themselves, they cannot. Cannot happen at the same time. All right, for example, you can't be a freshman and a senior at the same time. Those events are mutually exclusive. You're one or the other. You can't be in history and math 2 during fourth period. You're in one or the other. Are you okay? No. 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 All right. Two events are mutually exclusive if they cannot happen at the same time. The probability, now we're talking about probability. The probability of the two events happening at the same time is what?
0.
Good job. Does everybody see why it would be 0? Because it can happen at the same time. If it can happen at the same time, what's the probability that you're a freshman and a senior at the same time? 0. No. We're talking about here, right here. Okay. Here in high school, not high school in college or college, yeah, here in high school. All right. Shh, guys, stop the talking. Okay. Independent. Oh, there's a formula here. P for probability of A or B happening. Keyword there is A. The probability of you being, of an event A or B happening equals P of A plus P of B. Okay, you will need to know this formula. When they are mutually exclusive, the probability of A or B happening is probability of A plus the probability of B. Your notes, you need to be taking notes with the rest of us. All right, independent events, completely different from mutually exclusive. Again, up here, they're mutually exclusive or they're not mutually exclusive. Now we're talking about independent events or not independent events. Okay, what does it mean to be independent?
By yourself.
By yourself? Do you depend on anyone else? Other people's actions, does it affect you if you're independent? No. Okay, so they could, but not here in this type of problem. Two events, please stop the talking. Two events are independent. Two events are independent if the occurrence of the first event does or does not affect the probability of the second event.
It does.
Does or does not if it's independent. Does not. Affect the probability of the second event. Okay, for example, flipping a coin. If I flip a coin and it lands on a heads, and then I pick up the coin and I go to flip it again, does that heads affect what I'm going to get the second time? Does it? Is it more likely to get a heads again? No, if I'm flipping a coin, it does not matter what I flip the first, second, or even third time. Do you agree? Okay. If I have a bag of marbles, red, blue, and white, and I take one out and it's blue, and I throw it back in and shake it up and I want to take another one out, does my second one have any impact on that first blue one I took out?
No.
What if I took it out and do not replace it? Then it's dependent because now I have one less marble, one less blue, or whatever color it was. All right. Mendoza, you had your hand up?
What does that word say? It's the
Occurrence? Yeah, two events are independent if the occurrence of the first event does not affect the probability of the second event. All right, I have two formulas for this when we are listening. Listening. All right, probability of A and B equals P of A times P of B. All right, how is this formula different from this one up here? Or how is it the same? Okay, I hear multiplication, where over here it is addition. Any words over here that were different? Or an and. Or is addition, and is multiplication. And means they're happening together. For example, in the notes that we took here, this and is like the overlap, the piece here where it happens together, where it's an A in math and an A in English, where this is an A in math or the A in English. Do you see the difference? All right. Why do we not have an and formula over here? What did I just say? And is another word for the what? Starts with an O. And is another word for the overlap. So why do I not have an and formula up here? Because it equals 0. The probability of the two events happening at the same time, the overlap, is 0. It's like this here. You're in math 1 or you're in math 2. There's no overlap. Got it? Okay. Please pay attention. There is another formula here.
So like, you either have blonde hair or you have brown hair.
That's a hard one because there's shades of.
Bleach blonde hair.
All right. Guys. Okay. Probability of A or B. Is that like this one up here, A or B? The word or, yes or no? All right, it starts off very much the same. P of A, what do you think? Plus or times? Plus or is plus. Plus P of B minus, here's where it's different, P of A and B.
Is that an equation?
These are two different formulas, yes.
For independent events?
These two are for independent. This one's for mutually exclusive, and we're missing the second one because it's always 0. We're missing the first one, I mean. The A and B is always 0 for mutually exclusive because they never happen together. That's what it means to be mutually exclusive. Okay, why do we have this minus? What did I say earlier about the and? It's the overlap. Why do I minus the overlap? Because, let me show you here. Is there overlap in this one? Okay, so if I say the probability of kids getting an A in math, or right now let's just look at the numbers. How many kids are getting an A in math? 25 plus 35 is what? 60. How many kids have an A in English? Now listen, if I do 60 plus 75, what did I just do with the 35? I added it twice. I added it there with the 25 and the 30, and I added it there with the 40 and the 35. So what do? I subtract the overlap because I would have added it twice. A, B, minus the overlap. A plus B minus the overlap. Questions on that? You do need to know that for the test. Why do we minus the A and B? Because we would have counted it. I'm going to repeat the question. Why do I minus this overlap section, the A and B? Because I would have counted it twice. I would have counted it twice. All right, we're moving on. Calculators are needed at this point. Okay, this, yes. And is multiplication or is addition. And then when there's overlap, you subtract it if the overlap exists. All right, mutually exclusive. So that's the top section here. Probability of A is 0.6. Probability of B is 0.25. What is the probability of A and B? And I don't have a formula for that up here. What is it? 0. It's right here. The probability of the two events happening at the same time, that's the and, is 0. If you want to put that up here, P of A and B equals 0. Why? Because they're mutually exclusive. All right, probability of A or B. Is this the one where I just add or add and subtract? Just add A plus B or A plus B minus the overlap. If it's mutually exclusive, just add. Do that now. Probability of A plus probability of B. Write down the numbers, 0.6 plus 0.25. And when you're showing your work, there's not a lot of work to show here, but I do want to see these numbers that you're adding. Don't just give me an answer. All right, what do we get? So if you just go through and plug in your calculator and give me number, I'm not going to accept it. I need to see some of this work in here. All right, not A or B. What's the formula that we learned yesterday? We subtract it from 1 minus the probability of A or B actually happening. Please listen, ladies. Not A or B is 1 minus the probability of A or B happening. So what, did we already calculate A or B happening? Did we do it already? So it's 1 minus what? 1 minus 0.85. So this is where I told you guys yesterday you will need to know the formula. What's the answer? 0.15, 0.15, or 0.15. Guys, this is going to come up on tonight's homework. So if you're not listening now, I will know because you're going to ask me, what does this mean? Then I'm going to get mad for you not listening.
What does this mean?
I'm going to show you right now. All right. That tilde, that's what it's called, that little squiggly line, the tilde means not. When you see that, it's the same as saying not, the probability of not A or B. That tilde right there, that squiggly. Okay, for example, I wrote it in there. Probability of not Q equals the probability of actually writing it not Q. That's what it's equivalent to, which is 1 minus the probability of Q. So the tilde is equivalent to using what word? Not. Got it?
Okay.
Yes? All right. So the tilde means not, and not means 1 minus it happening. Okay. Moving on. Next set of problems. Mutually exclusive or independent? Independent.
Why'd you put 0?
Can anybody answer why number 1 is 0? When they're mutually exclusive, and is the overlap, and is always 0 when they're mutually exclusive.
Is that what the other ones say or?
Yes. All right. Now, this is independent. So, is number 1 or number 4 also 0? It is not. Why is number 1 0 with the and, but number 4 is not 0? Number 4 is independent, not mutually exclusive. Do you see the difference? So let's go to the mutually exclusive, Aaron. Let's go to the mutually exclusive or the independent formulas. What do I do with the A and B? I multiply them. So this one is not 0. We do 0.55 times 0.4. And that's the work you would show me and then plug it in your calculator. All right, so show me this. That's what you would write down on your homework. And then plug in your calculator one more time. Why do I multiply here but say 0 over here?
Independent.
This one's independent, where this one is
Mutual.
mutually exclusive. Mendoza, you need to be paying attention. Can you guys multiply it in your calculators? You all have calculators out there. 0.22. All right. C or D. Because it's mutually exclusive, am I using the shorter one or the longer one? A or B, C or D, the shorter or the longer? The longer, because it's mutually exclusive. All right, so that's going to be P of C plus P of D minus what? Yes. Not yet. They've been opening later. Minus probability of, in this case, C and D. All right, you need to be writing this down. Guys, does this formula make sense that I just got it right here? A plus B minus A and B. C plus D minus C and D. Why? Because it's independent. Yes? What is C? 0.55 plus what is D? 0.4 or 0.40 if you want to think of it that way. Minus, we already calculated C and D. What is it? 0.22. Plug that in your calculator. 0.55 plus 0.4 minus 0.22. Plug it in your calculator. Some of you guys are just sitting there with the calculators on your desk. What is it? Points. Thank you.
You're welcome.
Okay.
Point.
Once you add and subtract, it's 0.73. Okay. Not C or D means 1 minus the probability of C or D actually happening. Do you guys agree that's what not means? Gentlemen, do you agree that's what not means? 1 minus the probability that it does happen. Have we already calculated this probability?
Where did you get the 0.22?
We multiplied. Okay, so did we already do the C or D?
Answers are opening with the answers next to it.
Wait, what? It's plus.
Like number 4 goes along with number 4.
Yes. All right. Yes.
How do you point something added?
0.55 plus 0.40 is 0.95 minus 0.22 is 0.73. All right? Okay. All right, so 1 minus what? Since we already done the C or D part, 1 minus what? That's the work you're going to show on your paper tonight. What do we get as the final answer? Okay. Questions? 1 minus 0.73. You plug it in your calculator. All right. Okay. What, Tara?
It's Tara.
I did not.
I was being sarcastic.
Okay. So what was your question?
Oh, I said C or D. Because it looks weird.
Oh.
I found like the units like two different.
Like chord?
parentheses.
Probability of chord. Oh. I see what you're saying. All right. Number 6. Independent or mutually exclusive? Okay, I'm going to give you guys like a 2-minute head start. You might not even need that. Go. This is just like 4, 5, 6. Go. No, not yet, because they've been late lately. Get to work.
So 6 would be 0.
Hey. Get to work.
Oh, wait, never mind.
Dylan. I know, I was going to tell him good job at working. Thank you.
Thank you.
So we multiply 0.75.
All right, so E and F would be probability of E times the probability of F. 0.75, 0.2, 0.15. Keep working.
Oh, shoot.
E or F? Do I stop here or do I minus the overlap? Do I stop here or minus the minus the overlap? Why? Because it is mutually exclusive, not, I'm sorry, because it's independent, not mutually exclusive. All right, so plug in your numbers. What's the E and F? They didn't give me E and F up here. What's E and F if they didn't give me E and F up here?
0.15, right?
0.15. Plug it in. Anybody have it? Point what? 0.8. Stop the talking. Okay, help me out with the last one then. Can you just at least give me the formula or the work that you have on your paper?
CR1 minus P or
Okay, keep going.
Yeah, 0.2. I got it.
Okay, 1 minus what?
0.8.
0.8. And where's the 0.8 coming from?
The 7 or number 7. The
Okay, or
answer for E
0.80.
or F.
And what do we get?
0.2.
0.2 or 0.20. All right, talking needs to stop. Just another minute. Okay,
Okay.
guys. Number 10, flipping. Oh, determine if the events are mutually exclusive. Justify your answer. You're flipping a coin. You flip a tails in a coin or drawing an ace from a deck of cards. Can those two events happen at the same time? And I don't mean you're doing this separately, like are they mutually exclusive?
Yes.
Okay, I'm saying it wrong and I apologize. It's sounding wonky. Flipping a tails on a coin or drawing an ace from a deck of cards. Two separate things, not together like I said. Two separate things. Let me finish this really quick. I'm going to help you out with this one. It is no. They are not mutually exclusive because they can happen at the same time. Can I flip a coin and it land on heads and tails at the same time? No. All right. Drawing a spade of diamonds from a deck of cards. A spade of or diamonds. Now this does mean at the same time. You're pulling out one card. Can it be a spade of diamonds at the same time? No. So this is yes, they are mutually exclusive. They cannot happen at the same time. A student, you're choosing a freshman high school student or a junior. You're picking one kid. Can they be a freshman or a junior at the same time? No. So is this mutually exclusive? Yes. Again, they cannot what?
Happen at the same time.
They cannot happen at the same time. All right, next section. Determine if the events are independent. You flip two coins one at a time. You flip one. The probability of flipping a heads on the second coin after the first coin was flipped. We talked about this earlier. Is this independent? Yes or no?
Yes.
Yes, because your first flip does not affect your second flip. Do you agree?
Yes.
Dakota, you need to be paying attention. Whatever you're doing needs to stop, get your notes out, and you're working with us. All right. The outcome of the first flip does or does not affect? Does not affect the outcome of the second flip. Okay, you draw two cards with replacement. With replacement, you draw a jack or a king. Now, that means you take one card out, you put it back, you draw one card out, it's a jack. You put it back, and now you're going for a king. Does that first one have any impact on the second one? So are these independent? Yes, because the card was what? Because the card was replaced. Okay, same situation, but the card was not replaced. Without replacement, you take a queen out. You're going for an ace. Are there any less aces because you took the queen out? No, but there's a less what? There's a less overall card. So does it change your probability? Yes. So is this independent? No. And why is it? Because the card was what? The card was not replaced. Do you see the difference? If you replace the card, you replace the marble, it doesn't have any effect on your second card or your second marble. But if you do not replace it, you have one less card or one less marble overall. Questions?